Hello everyone. In this video, we are going to be solving AQA GCSE Chemistry June 2022 foundation paper. We are going to be solving part 3 of the video, in which we are going to be solving from question number 8 to question number 10. This question is about electrolysis. Ionic compounds decomposes when they are electrolyzed. A student electrolyzes sodium sulfate solution. Figure 13 shows the apparatus used. Hydrogen is produced, oxygen is produced, measuring cylinders, electrodes, sodium sulfate solution, and DC power supply. Great. Sodium sulfate contains hydroxide ion, hydrogen ion, sodium ions, and sulfate ions. Guys, it's better to know their formula, so I'm just gonna write it down for you. You can try to remember it. Oxygen is produced at the positive electrode. Which ions are discharged at the positive electrode to produce oxygen? So, as you can see, in positive electrode, we are always going to get negative ion. And there are two negative ions, hydroxide and sulfate. By default, according to our exam, we are going to learn that sulfate cannot be discharged in the positive electrode. So, hydroxide ion will be the answer. Figure 14 shows one of the measuring cylinders during electrolysis. So we can see this measuring cylinder is inverted. So we're going to read it 21. So this will be 25, 26, and this will be 27. So the volume here we are reading is 27. Ionic compounds can be electrolyzed when molten or dissolved in water. Why can ionic compounds not be electrolyzed when solid? You see, ionic compounds, they have a solid lattice structure, where you can see in the case of sodium chloride, the ions are fixed in their position. They cannot move. So since the ions are unable to move, that's why they cannot conduct electricity. They do not even have any free electrons which will be able to conduct electricity. So the answer will be ions cannot move freely in a solid. Table 7 shows the product of electrolysis of two molten compounds. We can see potassium iodide. Okay, so in potassium iodide, since it is molten, we're going to get potassium, and in the positive electrode, we're going to get iodine. It's very simple. In zinc bromide, since it is molten, we got bromine on the positive, so we're going to get the zinc in the negative. The electrolysis of molten sodium chloride is used to extract sodium metal. Why is sodium metal extracted by electrolysis instead of reduction with carbon? Sodium is very high in the reactivity series, and carbon is way lower in the reactivity series. That's why carbon is unable to displace sodium from its chloride. So here it says carbon conducts electricity, not a reason. Carbon is less reactive than sodium. Yes, carbon reduction uses more energy. No, it's not possible. What is the state symbol for molten sodium chloride? Anything that is molten should be liquid. Titanium can be produced from titanium oxide by electrolysis. The equation is shown here. Calculate the percentage atom economy for the production of titanium from titanium oxide by electrolysis. Okay, so percentage atom economy, and according to the formula, mass of desired product, which is our titanium 48, divided by mass of all of the reactants, which is TiO2, and mass is 80, multiplied by 100. So this gives us an atomic economy of 60%. This question is about metals and nonmetals. Figure 15 shows an outlined part of periodic table. We can see A. We know that A represents, it represents the alkali and the alkaline earth metal, and B represents the transition element. C represents C also represents metals. However, this is in the block P block. Alright, and D represents nonmetal. Element Q is a dull solid with a melting point of 44. So dull solid is an indication for nonmetal. And melting point of 44, low melting point, is also an indication of nonmetal. So very likely Q will belong in block D. Element Q does not conduct electricity, also an indication of nonmetal. Nonmetals do not conduct electricity. Which section of periodic table in figure 15 is most likely the element to contain element Q? So we are going to get element Q most likely in D. Element R forms ions of formula R2 plus and R3 plus. Which section of periodic table in figure 15 is most likely to contain element R? Okay, since we can see that it has multiple oxidation state of 2 plus 3 plus, this is a indication of transition element. So transition element here is represented in B. So B should be the answer. Give two differences between physical properties of the elements in group 1 and those of the transition element. Okay, so in terms of physical properties, we know that group 1 metals, they are they're like lightweight, so they are less dense. All right, and they have low melting point, they are less dense. All right, and when it comes to transition metal, in contrary, all right, they are dense metals. All right, they are hard. Group 1 metals are soft. All right, and if we talk about other physical properties, is the transition elements have very high melting point and boiling point. So since the question says to write about group 1 metals, so we will have to write about group 1 metals only. And finally, guys, an added point, G1 metals are softer. Complete figure 16 show the electronic structure of aluminium atom. So aluminium in the periodic table, if you check, it has a proton number of 13. That means it has also 13 electron. So the electronic configuration would be 283. Aluminium is a metal. Describe how metals conduct electricity. Answer in terms of electron. Okay. So when we talk about a metal is the bonding between delocalized electron and its positive ion. And the delocalized electrons are able to carry charge. They are able to move throughout the metal structure. So they are able to carry that particular electricity throughout the metal. Name the type of bonding in compounds formed between metals and nonmetals. So when metal bonds with a nonmetal, it should be an ionic bonding. The metal forms the positive ion and the nonmetal forms the negative ion. Magnesium oxide is a compound formed from the metal magnesium and the nonmetal oxygen. Describe what happens when a magnesium atom reacts with oxygen atom. You should refer to electrons in your answer. So basically, a magnesium atom loses electron. If we look into the periodic table, magnesium belongs to group 2. So thereby magnesium loses 2 electrons to form a 2 plus positive ion. Whereas the oxygen belongs in group 6. So takes in 2 electrons to form O2 minus negative ion or oxide ion. Alright. And the oxygen gains the electron. Magnesium ions and oxide ions are formed, and because they are oppositely charged, so they attract each other and form a giant lattice structure. The answer should be written as follows. Sodium carbonate reacts with hydrochloric acid in an exothermic reaction. The equation for the reaction is sodium carbonate reacting with hydrochloric acid producing sodium chloride, carbon dioxide and water. A student investigated the effect of changing the mass of sodium carbonate powder on the highest temperature reached by the reaction mixture. Plan a method to investigate the effect of changing the mass of sodium carbonate powder on the highest temperature reached. Okay, guys, in a question like this, all right, first of all, we would have to have a pretty good volume of hydrochloric acid, all right, because we're going to use the same amount of hydrochloric acid in all of the experiment. So we're going to measure the volume of hydrochloric acid using a measuring cylinder, and then we're going to pour the hydrochloric acid into a suitable container, for example like a polystyrene cup, all right, and we're going to measure the initial temperature of the hydrochloric acid when when that particular hydrochloric acid is in that cup. Guys, this particular part is very important because if you are dealing with concentrated hydrochloric acid, just pouring from one container to another container may increase its temperature, all right. So we're going to measure the temperature using a thermometer, all right, and then we're going to add like a known mass of sodium carbonate. For example, like maybe let's say 5 grams of sodium carbonate will be added, okay, and this 5 gram, all right, will be measured with a balance, okay, and then we're going to stir and we're going to see the highest temperature that is reached. Then we're going to repeat that same experiment, all right, with a different mass of sodium carbonate. For example, the next time maybe you're going to be using 10 grams of sodium carbonate, and repeat the whole investigation again and again, all right, using the same starting temperature of the hydrochloric acid and same volume of acid each time and same concentration of acid each time to make the experiment fair. Guys, I know the point that I have told is like way more than this particular question supports as a mark. However, you see, the idea is you have to write a complete answer, okay. So it can exceed the mark. The maximum mark is 6 mark. However, we need to write a complete answer. The reason being is that if we want to get the full mark, which is the 6 mark, all right, then we're going to be considered in level 3, and the method would lead to the production of a valid outcome. The key steps are identified and logically sequenced. So as you can see, if we write a complete answer, only then we're going to get 6 marks, all right. That's why we need to write more and logically, okay. Figure 17 shows a line of best fit through the student's result. Okay, mass of sodium carbonate in grams, highest temperature reached by the reaction mixture in degrees Celsius. Determine the gradient of the line of best fit in figure 17. Alright, so we are allowed to use this equation, change in the highest temperature divided by change in mass. Alright, so we'll have to find it out. Alright, here we can see alright, at 1 gram of sodium carbonate, the temperature recorded was this is 23, so this will be 22.2. okay, and the highest temperature recorded was at 5 grams, it was 28.6. so first of all, change in temperature. So this will be 28.6 minus 22.2, which is equals to, so highest temperature change is 6.4 degrees Celsius. Alright, the next one will be change in mass. So we can see the change starts from 1 and ends in 5. So 5 minus 1, 4. Alright, so if we want to find out the gradient, so the gradient is equals to 6.4 divided by 4, which gives us 1.6. And because the gradient is in degrees Celsius over mass, which is gram, so degrees Celsius / gram. So 1.6 degrees Celsius / gram will be our unit. The initial temperature of the reaction mixture is where the line of best fit would meet the y-axis. Determine the initial temperature of the reaction mixture. Okay. So to determine the initial temperature of the reaction mixture, we just have to extend the line and meet it. So we can see it's 20.6. So 20.6. Another student repeated the investigation but added sodium carbonate until the sodium carbonate was in excess. Which sketch graph show the result obtained when sodium carbonate was added until in excess? Okay, so highest temperature reached and plateaued. So should be C, because at this point the reaction has stopped because the sodium carbonate was in excess, so there was no more increase in temperature. Figure 18 shows the reaction profile for the reaction of sodium carbonate with hydrochloric acid. We can see X represent energy change or enthalpy change, and Y represents overall energy change. So X represents energy and Y represents overall energy change. So what do the level X by? Okay, we did this already. How does the reaction profile show the reaction is exothermic? The reaction is shown exothermic because product has less amount of energy compared to that of the reactant. So heat energy must be lost. The answer should be written as follows. Alright guys, so that's the end of this particular question paper. Thank you for joining the class today, And guys, subscribe to the channel, all right, and tell your friends about that this particular channel is uploading these question paper videos, all right, regularly. And if you have any question paper in your mind that you want me to solve, you can put it in the comment, you can email me, all right, and definitely I'm gonna help you out with that. Okay guys, see you in the next video. Bye bye, best of luck with your exam.